Hey guys, welcome back. Now, suppose that you were curious to know the relationship between how many minutes you studied for a test and the score you would then get. So, if you studied for 0 minutes, you're not going to get a zero. And you found that you got a 70. Okay, and then test two came along, and then you studied for 15 minutes at time, and then you got a 75. And then the third test, you studied half an hour, you got an 83. And then the fourth test, you studied for 45 minutes and got an 88. And now you might want to know, okay, based on these past experiences, can I predict what score I will get on a future test based on how many minutes I studied? And the answer is yes, we can somewhat get a prediction. Now, of course, in practice, there are other variables like how difficult the test is and how well you know the material. There are other factors here. So just humor me with the sake of using the data. I do understand that the example maybe isn't a perfect one, but it will be mathematically accurate, just not maybe as practically useful. Okay, so, what if I studied an hour? What score am I going to get? What if I need to get a 95 on a test? How many minutes do we need to study? We want to be able to answer these questions. However, we can't do that based on the data we have so far. We have to do a little manipulation to it. And we're going to use Google Sheets to aid us. And basically, we want to determine the linear relationship. We do see that there's a correlation. As minutes studied increases, so does your test score. There is definitely a correlation here. And when there's a correlation, a linear correlation, we could then determine a line of best fit, some kind of equation to help us most accurately predict future outcomes. So let's do that. We're going to ignore column B because just telling me like the number test doesn't really have any mathematical significance. So we're going to be focusing on column D and column C. You're going to highlight it, hit insert, and then do a chart. And the default, for at least for me, was the line chart. No, I actually want a scatter chart right here. Okay. And if you highlight the tops right here, it actually does a pretty good job of labeling your graph already. Okay, now we have these four test scores on the chart. 0, 70, 15, 75, 30, 83, 45 as the x, comma, 88 as the y, right? These are things that you've done in your algebra days. However, this still doesn't help us determine which score we're going to get if we study it for an hour, or how many minutes we need to study if we want to get 95. So we need to add a trend line, a line of best fit. So to do that, you can right click and go over here to series. No, I'll have the better way. Just double click just double click. Okay, and then over here you're going to go to customize. And then under series, if you scroll down, we have trend line. You're going to turn that on. And that will add a line that basically threads the needle as best as possible between your data points. So it might look like it's hitting through all four lines, and that might be the case in some times, depending on how correlated the data is. But right here, it's probably a little bit below it. Right here, it's a little bit above it, lower, higher. It's going to be splitting the difference. You'll have probably around half that are above, half that are below. And the distance above is going to be equal to the distance below. But you don't have to figure that out. That's the beauty of this. Okay, so now we're going to go to, scroll down a little bit further, and where it says label, you're going to do use equation. And this equation right here is showing us what the equation of this line is. We have y equals 0.413x plus 69.7. Meaning, if x equals minutes studied, the y is going to be what score you got. So if you studied 0 minutes, this is predicting that you're going to get a 69.7. Pretty close to the 70, which we actually observed. If you want to study 60 minutes, you plug in 60 here, and then whatever your output is what your score is expected to be. If you want to know what score you want to get, you can plug that in for the y, and then see how many minutes you need to study to get that. So for each minute you study, you can expect your score to increase by 0.413 percentage points. The last thing is over here, if you click show R squared, here is where you can see your how linear your lines are. And an R squared of 0.991 shows a very strong linear correlation. If you want to get your R value, there's no, I wish there was. I wish there was like a little button here I can just click that says show me the R. But unfortunately, it's not that simple. So we're going to come over here, and it's actually a formula to be able to get that. So I'm just going to type over here just so I know what I'm looking at. So I'm just going to type in, what's it called? Correlation coefficient. Did I spell that right? Sure. R. I'm going to center that, make it look good. And in this cell right here, I'm going to type in the formula to get that. And here's what it is. It's equal CORR correlation. Click on it. Then you have to highlight the data, not the title. Make sure you leave the title out. The data of column 1, comma, the data in column 2, and then boom. And it's 0.995. Very, very, very strong correlation. Very strong correlation. And if you were to square that value, I come over here, and then I want this cell to be equal this value squared. You will find that we get our R squared anyway. But this way is a little bit easier. So we do have to use that formula to be able to get the R value of our data. Okay.